Here's a presentation of my MAC2233 Calculus for Business and Social Sciences project. I created a business called Just Eat It. It's a new company that's making edible cutlery to reduce the use of plastics and waste in the world. Our cutlery is made of organic corn and can be eaten or composted. We use the finest organic corn to produce durable, quality, and sustainable cutlery. Your meal is not over until you eat your fork. And I tied it to Sustainability Development Goal number 12, which is ensure sustainable consumption and production patterns. One of the goals' intention is to reduce waste. The challenge is there's a major problem in the United States and world with waste and plastics. According to NPR, every year the average American goes through more than 250 pounds of plastic waste, and much of that comes from packaging. And according to BBC News, the world produces over 2 billion tons of municipal solid waste every year, enough to fill over 800,000 Olympic-sized swimming pools per head of population. The worst offenders are the US, as Americans produce 3 times the global average of waste, including plastic and food. And Just Eat It has the mission to reduce the use of plastics in the United States and world, as well as to reduce the amount of waste produced. Its solution is to produce cutlery, forks, spoons, knives, made out of organic corn as a replacement for plastic cutlery. The goal is to reduce the use of plastics and waste in the United States and the world. This is my logo for Just Eat It and an advertisement for Just Eat It, where you're not done with your meal until you eat your fork. The topic that I'm dealing with is derivative, first derivative, and second derivative. The derivative is defined as a function's instantaneous rate of change at a certain point, and a second derivative is the derivative of the first derivative. Applications of the first derivative are like marginal cost, marginal revenue, marginal profit, finding extrema, finding elasticity of demand, and many others. Applications of the second derivative are acceleration of sales, finding inflection points, finding concavity, and many more. I chose this project to find the rate of change and acceleration of sales for Just Eat It. This will allow me to track how sales are changing month by month through the first derivative. This will allow me to make production decisions monthly on how many cutlery to produce. The second derivative will allow me to see how changes in sales is changing monthly. This will allow me to react monthly to how the sales are changing by adjusting production. Applications of a derivative are marginal cost, marginal revenue, marginal profit, finding extrema, finding elasticity of demand, and many others. Applications of the second derivative include acceleration of sales, finding inflection points, finding concavity, and many more. I created some data for this project. So in month 1, sales were 6,000. Month 2, sales were 8,300. Month 3, 10,500. Month 4, 13,100. Month 5, 10,500. Month 6, 8,200. Month 7, 5,800. Month 8, 3,900. Month 9, 6,300. Month 10, 8,500. Month 11, 11,100. Month 12, 14,000. My input is month, my output is sales. I created a scatter plot of the data. And when I did cubic regression of the data, I got S of t equals 78.97 t raised to the third minus 1448.34 t squared plus 7291.34 t plus 129.29. And this equation is based on the cubic regression of data. The input is month, the output is total sales. And the question I'm going to ask in my project are, what are the total sales after 2 months? What are the total sales after 7 months? What's the rate of change after 2 months? What's the rate of change after 7 months? What's the acceleration after 2 months? What's the acceleration after 2 months? What's the acceleration after 7 months? When are the months of the acceleration of sales are positive? What months of the acceleration of sales negative? And what are some other applications of second derivative? I created a scatter plot of my data, and the regression line, as you see, models that data. So, first of all, to find total sales after 2 months, you plug 2 into the original function, and you get total sales at month 2 is 9,291.80. After total sales after 7 months, again, we plug 7 into the original function, so total sales at month 7 is 7,028.14. And the rate of change after 2 months, you take the first derivative and plug in 2. And after taking the first derivative, you get at month 2, the rate of change of sales is increasing $2,445.62 per month. To find the rate of change after 7 months, again, you take the first derivative, plug in 7, And at month 7, the rate of change is decreasing $1,376.83 per month. To find the acceleration of sales after 2 months, you take the second derivative, plug in 2. So at month 2, the sales are decelerating at $1,949.04 per month squared. And to find the acceleration of sales after 7 months, you take the second derivative, plug in 7. So at month 7, the sales are accelerating at $420.05 per month squared. I use my graphing calculator to find that the months that the sales are accelerating is months 7 through 12. That means for those months, the rate of change of sales is increasing. And the months the acceleration of sales are negative, the months the sales are the acceleration is negative is months 1 through 6. That means for months the rate of change of sales is decreasing. And some other applications, second derivative is finding inflection points, finding concavity, and many more. I learned many things in this project. First of all, I was able to learn that collecting data is important for business. The data can be used as a regression to estimate and predict how the sales are changing over time. Secondly, I learned that the first derivative can estimate the rate of change of sales at a given time period. This can help me predict how sales are changing, so adjustments in production, staff, costs, and others can be made. Thirdly, I learned that the second derivative can estimate how the rate of change is changing. This can help to adjust monthly as your rate of change is changing. Overall, I learned that we can use calculus to help predict things are changing to help improve sales over time. It's essential that businesses used data to improve their performance and increase sales and profits. And then finally, I learned that sustainability is important not only to the world, but to business. Sustainability is important to consumers and is the responsibility of everyone, including businesses. And this is my presentation. Thank you.